Welcome to Sleeping with Science. It's good to have you here tonight. Before we begin, take a moment to settle in. Maybe you're lying under a warm blanket, perhaps sitting back in a quiet room, or listening while the world outside still hums with its own rhythm. However you've arrived here, this space is yours. Nothing is required of you, except to listen and let your mind drift. These videos are made to help you rest, and if you drift into sleep quickly, that's wonderful. But if your thoughts stay awake a little longer, that's fine too. In the meantime, you'll carry something with you: gentle knowledge, small fragments of wonder about the world and the science that shapes it. And before we journey into tonight's story, a small request. If you enjoy spending these quiet moments with us, a like and a subscribe really helps this channel grow. It allows us to make more of these meditative explorations, weaving science into calm reflections designed to help you rest. Now let's begin. Tonight we open the story of the sun and of the brilliant eruptions known as solar flares, fireworks of the heavens. But before we can understand those bursts of light and energy, we must travel inward, to the very heart of the sun itself. Deep within the sun, far below the glowing surface you see in the sky, lies a place of unimaginable pressure and heat. It is here, in the core, that the sun's power is born. Atoms of hydrogen, the simplest element in the universe, are pressed so tightly together that they merge, forming helium. This process is called nuclear fusion, and it is the slow, steady heartbeat of our star. It doesn't happen with violence or suddenness, but with patience. In every instant, countless hydrogen atoms combine, releasing energy that will one day shine on your skin, warm the oceans, and allow plants to grow. The scale is beyond comprehension. Every second, the sun turns millions of tons of matter into light. Yet from our distance, it feels calm, steady, almost eternal. What begins as the quiet union of atoms becomes the radiance that fills our days. A solar flare is a moment of sudden drama, but beneath it lies this continuous, patient engine, the sun's core, working silently, endlessly, without pause. As you rest tonight, picture yourself drifting closer to that hidden heart. Picture the slow pulse of fusion, a rhythm older than life, steady and enduring. You don't need to hold on to every detail. Just let the thought rest with you, that every breath you take, every light that falls across your face, comes from a quiet fire burning millions of kilometers away. And if sleep begins to gather around you now, let it come. The story will continue whether you listen to every word or not. For now, you are safe, you are at rest, and the sun keeps its heartbeat steady, as it has for billions of years. Last time we drifted into the sun's hidden heart, where fusion quietly shapes the future of every sunrise. Tonight, we follow what happens next. When energy is born in the core, it does not rush outward all at once. Instead, it begins a journey so long and meandering that it reshapes how we think of time itself. Imagine, if you can, a single photon, one tiny packet of light. It is created in the dense core, in a place where the pressure is so immense that particles jostle like crowds pressed together in a space too small to move freely. This photon's path outward will not be straight. It will not glide smoothly to the surface. Instead, it will be knocked and scattered endlessly, ricocheting from one particle to another, zigzagging with no clear direction. To you, light feels instant. You flip a switch, and the room brightens in less than a heartbeat. But the light we see from the sun's surface is ancient compared to that speed. It may have spent tens of thousands, even millions of years bouncing inside the sun before finally reaching freedom. By the time it escapes and begins its swift journey to Earth, the moment of its creation is far in the past, buried in ages we cannot touch. This slow wandering is called the radiative zone, a realm where light crawls instead of flies. Each collision alters the photon's path, sending it sideways, backwards, sometimes deeper into the layers it was trying to leave. Progress is measured not in steps but in lifetimes, and yet every photon continues, patient, persistent, carrying with it the memory of fusion's fire. Eventually, after a span longer than the rise and fall of species on Earth, the photon reaches a region where movement changes. Here, in the convective zone, currents of plasma lift energy upward in great loops, like vast tides moving through the body of the Sunday. Now the photon is swept along, carried upward more swiftly, until at last it reaches the surface, the photosphere, and steps into open space. From that moment the story changes. What once took millennia is now completed in minutes. In just over 8 minutes, light travels the 93 million miles between the Sun and Earth, streaming across the void with perfect speed. The photon that was once trapped in timeless wandering now blazes across space in the blink of an eye, ending its journey when it touches a leaf, a wave, or perhaps your skin. There is something humbling in this. The light of day is not a sudden gift but the result of an ancient journey. What brightens your window in the morning may have been struggling through the sun's depths, since long before the first humans walked the earth. As you listen, let that thought carry you into rest. The light that falls so casually through your world is not casual at all. It is patient, enduring, and older than memory. When you close your eyes tonight, imagine yourself floating with those photons, moving slowly at first, then rushing free, crossing the dark to arrive here, now, just for you. If you picture the sun as a ball of fire, you are both right and not quite right. Fire, as we know it on Earth, is a flicker of chemical reactions, flames fed by oxygen, fragile and short-lived. The sun is different. What fills its body is not gas as we breathe it, nor liquid as we drink it, but something stranger, something alive with charge, a state of matter called plasma. Plasma is often described as the fourth state of matter, standing alongside solid, liquid, and gas, but it feels less like a sibling and more like a transformation beyond them. In plasma, atoms lose their grip on electrons. Particles break apart, creating a sea of charged fragments, protons, electrons, free to move, to swirl, to flow in ways unlike anything else. It behaves with contradictions. Plasma can roll and surge like water, but it can also shimmer like flame. It bends to magnetic fields as if they were invisible strings, yet at the same time it generates those very fields through its own restless currents. It is not fixed, not still, never truly calm. On Earth, we rarely see plasma in its natural form. A lightning bolt tearing through the sky is plasma. The glow inside a neon sign is plasma too. Both are fleeting, flashes and glimmers. But on the sun, plasma is not a spark, it is the whole. The sun is almost entirely made of it, oceans of seething particles stretching millions of kilometers deep. Within this roiling sea, order and chaos are partners. Magnetic loops rise from the surface, twisting plasma into great arcs. Waves ripple across it, carrying energy from deep within to the surface above. Nothing rests, not even for a moment. The sun's surface may look still from far away, but up close it is alive. Every particle in motion, every current feeding the next. This constant unrest is essential. Without plasma's strange nature, magnetic fields could not twist and build. Without those fields, there would be no solar flares, no sudden bursts of light and energy. Plasma's restlessness is the foundation for every storm the sun produces. As you lie here, imagine standing at the edge of that restless ocean, not with heat, not with danger, but with quiet wonder. Picture waves of particles moving endlessly, neither liquid nor flame, but something in between, something uniquely its own. It is a reminder that the universe is not bound by the categories we find familiar. Matter has more stories than solid, liquid, and gas. Plasma is one of them, a state of perpetual change, a sea that never knows stillness. Let the image drift with you. Not fire, not water, but a living glow, vast and unquiet, filling the sun from its surface to its depths. A body of matter that never rests, yet has burned with endurance for billions of years, carrying us through every season and every night. Beneath the surface of the sun, the story of plasma is never just about heat or light. Moving charges, electrons and protons drifting freely, create something invisible yet powerful: magnetic fields. These fields do not float separately from the Sunday, they are part of its body, woven through the plasma like threads through fabric, bending and shaping the restless matter around them. Think of them not as straight lines, but as loops, arcs, and spirals that twist and fold across the sun's surface. They are sculpted by the sun's rotation, by convection currents deep within, and by the endless motions of particles slipping past one another. In this way, the sun becomes not only a furnace of fusion but a loom of magnetism, spinning invisible threads across its vast body. We cannot see magnetic fields directly. What we notice instead is their influence. A field line tugging here, a current pulled there, arcs of plasma rising into shapes that would not exist without that invisible hand. On Earth, you might picture iron filings aligning to show the presence of a field. On the sun, entire rivers of plasma align in vast loops, tracing out shapes millions of kilometers long. Magnetism carries tension. Where lines are smooth, they guide particles gently, but where they tangle, they store energy, coiling tighter and tighter until something must give. These knots of magnetism are where solar flares will one day be born, sudden releases of power that ripple outward. But even before a flare, these invisible structures shape the sun's surface, creating dark sunspots where fields grow strongest and bending plasma into patterns like vast sculptures in motion. Magnetism is paradoxical. It is intangible, yet it shapes what we see. It is silent, yet it drives eruptions that echo across space. It is invisible, yet it leaves fingerprints everywhere, on sunspots, on arcs of light, on the storms that eventually reach Earth. Picture the sun not just as a ball of fire, but as a tapestry. Each thread is magnetic, guiding, twisting, holding, and sometimes snapping. The visible surface, the glow you see from Earth, is only the fabric's face. Beneath it lies the weave, unseen but essential. Tonight, let that thought rest with you. The warmth on your skin, the sunlight brightening your day, is not only the result of fusion at the core, but of magnetism shaping the way energy flows. The sun is not just light. It is structure without form, patterns without edges, threads of force woven into fire. And as you drift, imagine those invisible threads crossing and winding, quiet and patient, until at last they are ready to release their hidden strength. That release, sudden and bright, is a solar flare. But for now, you are at ease, wrapped in the thought that even in the most violent stars, order and pattern live within chaos. If you could stand above the sun and look down, past its glow and into its living surface, you would see something extraordinary, not a static face of light, but a pattern of movement, an endless circulation of hot gases rising and sinking. This is convection, the dance of energy moving upward and downward, shaping the sun's surface into a restless mosaic. Picture a pot of water slowly warming on a stove. At first it looks still, but as heat rises, currents begin to form. Hot water at the bottom climbs upward, while cooler water sinks to take its place. The surface shimmers, swirls, and rolls in patterns that continue as long as the heat is there. On the sun, the principle is the same, but the scale is beyond measure. Instead of water, it is plasma, and instead of centimeters, the patterns stretch across tens of thousands of kilometers. These rising and sinking motions carve the sun's surface into vast cells called granules. Each one is immense compared to anything familiar, larger than continents, yet fleeting, lasting only minutes before dissolving into new patterns. From Earth, through telescopes, the sun appears mottled, textured, like hammered metal. But each bright patch is plasma rising, each darker edge plasma cooling and sinking again. It is a cycle without rest. Energy from the sun's deeper layers reaches the convective zone, where heat cannot pass smoothly by radiation alone. Instead, the plasma carries it upward physically, like great columns lifting warmth toward the surface. Once it cools, it descends again, pulled down to repeat the journey. Billions of these cycles unfold at once, weaving the surface into an ever-changing patchwork. This constant motion shapes more than appearances. Convection drives the sun's magnetic activity, twisting and stretching the invisible fields that thread through plasma. It feeds the very tensions that will one day release as solar flares. What looks like a quiet shimmer is, in truth, a restless heartbeat, pumping energy toward the surface in patterns too vast for human eyes to fully hold. And yet, there is beauty in this ceaseless churn. Imagine it not as chaos, but as a rhythm, rising, falling, rising again, a balance of opposites, always repeating, always renewing. The sun breathes through these motions, exhaling heat into space, inhaling coolness from its surface. It is not a breath you can hear, but it is as steady as the pulse of time itself. Let yourself drift with that rhythm, rising warmth, falling coolness, cycles that continue without end. The same motion that stirs tea in a cup or air in the sky is echoed on the sun in a scale too immense to imagine. The universe repeats its patterns, from the smallest to the greatest, from your breath tonight to the convection cells of a star. The sun is not still. It spins, slowly at the poles, more quickly at the equator, its body turning with a rhythm that takes weeks to complete a single rotation. This uneven motion, combined with the endless rise and fall of convection, creates something hidden but essential. A vast dynamo, an engine without wheels or pistons, forging magnetic fields in silence. On Earth, dynamos are machines we build. They use coils of wire and moving parts to generate electricity, turning motion into current. The sun's dynamo is not built of metal or wire. It is built of plasma, moving in colossal patterns, its charged particles stirring and twisting under the influence of rotation. Where plasma flows, magnetic fields arise, threading outward and looping back again. This process is neither sudden nor chaotic. It is slow, patient, almost geological in its rhythm. Over years and decades, the dynamo strengthens and weakens, winding magnetic fields tighter, then letting them relax. These cycles give rise to the waxing and waning of sunspots, to the periodic surges and calms of solar activity. What we see as bursts of light in the sky begins as a steady turning deep within, the invisible work of the solar dynamo. It is a paradox. From this unhurried process, plasma drifting, rotation bending, magnetism slowly weaving, comes the violence of solar flares. Energy builds quietly, unseen, stored in tangled fields, until at last the balance tips and release comes in an instant. A flare is born in seconds, but its preparation takes years. See the sun, then, not only as a star, but as a vast engine humming below the threshold of perception. You cannot hear it, cannot feel it, yet it is always working, converting movement into fields, fields into energy, and energy into light that travels across space to reach Earth. Every spark, every eruption, every shimmering aurora traces its roots back to this hidden dynamo. Think of slow cycles turning quietly, not in gears or cogs, but in flows of plasma across a star. Think of patience, how the universe prepares its sudden moments with long stretches of unseen work. Even in your own life, what looks like a sudden change may have been building slowly, quietly, waiting for its release. The sun's dynamo continues, always weaving, always preparing, an engine of silence that powers the fireworks of the heavens. When you look at the sun through a telescope fitted with the right filters, its brilliance softens enough to reveal markings across its face. Not uniform, not smooth, but dotted with patches, dark, irregular shapes that seem like imperfections on a glowing canvas. These are sunspots, regions where the sun's hidden fields rise to the surface, bending plasma into shapes that alter the very light we see. Sunspots are not truly cold. They are only cooler than the blazing surface around them, thousands of degrees lower, but still hotter than any fire on Earth. Their darkness is an illusion born of contrast, shadows against a brighter backdrop. They form where magnetic fields tighten and knot, pressing so strongly that the flow of heat from below is slowed. In these places, the sun's energy hesitates, creating a dimmer patch, a window into the struggle between rising heat and constraining fields. To the naked eye, the sun is blinding, perfect in its glow, but sunspots remind us that beneath that brilliance, there is complexity, turbulence, and structure. Each spot can grow larger than our planet, a shadow vast enough to dwarf all the landscapes we know. And yet, they shift and fade, appearing in cycles, waxing and waning with the rhythms of the solar dynamo deep inside. These dark regions are not merely curiosities, they are portals of knowledge, signals of the sun's changing moods. For centuries, astronomers tracked their numbers, sketching patterns long before modern instruments existed. They noticed that when spots grew more numerous, the sun became restless, more likely to produce flares and storms. When the spots faded, the star entered calmer phases. What seems like a blemish is, in truth, a signpost. Sunspots are evidence of hidden power winding tight beneath the surface, energy stored in tangled magnetic fields that may one day snap and release. They are reminders that what appears calm from Earth is never truly still. While your thoughts drift, think of the sun not as flawless light, but as a canvas with shifting shadows, each one a doorway to the mysteries below. These shadows are not flaws, they are the star's own handwriting, scribbles across its face that tell us of cycles, tensions, and the potential for sudden brilliance. Tonight, let that image settle quietly with you. Even in the brightest places, shadows exist, not as endings, but as hints of depth, of complexity, of forces at work beneath the surface. The sun wears its spots as signs of its inner life, and through them we glimpse the vast hidden machinery that powers both its calm glow and its violent storms. And if your eyes close now, let the thought drift with you, that in every light there is shadow, and in every shadow a story waiting to be told. Looking at the sun, we see radiance, steady, overwhelming, impossible to view without protection. But hidden beneath that light is a structure more fragile and more powerful than it appears. Magnetic fields threading through plasma, shaping motion in ways that cannot be seen directly. These fields are not smooth or ordered. They twist, they cross, they coil around one another in patterns that hold immense energy, waiting quietly until balance gives way. Magnetic field lines are not objects you can touch. They are pathways, invisible trails that charged particles follow as they move. Yet in the sun's body, these lines take on substance in their effects. They bend plasma into arcs, trap energy within loops, and sometimes stretch across regions larger than Earth itself. The fields are restless because the sun itself is restless. Plasma churns and rotates, carrying the lines with it, twisting them into knots, tangling them like threads pulled too tight. As these lines twist, they store energy. Imagine a spring wound slowly, turn by turn, each coil holding more tension than the last. The spring does not snap immediately. It waits, holding its potential until the strain is too much. The sun's magnetic lines behave the same way. They coil and tangle, storing energy not in steel but in invisible fields, silent until the moment of release. When two lines cross, something remarkable can occur. The fields can reconnect, breaking and reforming in an instant, rearranging themselves into simpler patterns. In that brief act of reconnection, energy is unleashed, not gradually but explosively, hurling particles outward, heating plasma to extraordinary temperatures, and lighting the solar atmosphere with sudden brilliance. This is one of the key triggers of a solar flare, a transformation that takes seconds but builds over years. What is humbling is the scale. On Earth, a spark of static electricity may startle you with a crackle. On the sun, the same principle is magnified into forces that dwarf entire planets. A single reconnection can release more energy than humanity has ever produced in its entire history. And yet, from 93 million miles away, this violence appears to us as a flicker, a brief change in light, or a ripple in space weather recorded by instruments. The sun, then, is not simply a glowing sphere. It is a place where invisible lines weave and knot, where energy is hidden in forms our eyes cannot see. The surface is only the face of a deeper struggle, one of balance and tension, patience and sudden release. Every flare that ever lights the sky is born from these tangled lines, from fields wound tight until they can hold no more. As your mind grows quiet, picture not fire or flame, but invisible threads stretched across a star, lines that loop and twist until they are ready to snap. Let the thought carry you gently toward rest, that even the brightest light conceals invisible patterns, and even in silence, immense forces are preparing their release. If you could hover above the sun, watching its surface over days and weeks, you might notice something subtle, something almost imperceptible. The face of the star is never truly calm, but there are moments when the activity changes character. Patterns shift, the restless surface seems to gather itself, as if holding its breath. It is in these pauses that the seeds of a solar flare are sown. From Earth, this stillness is invisible to the naked eye. The sun shines with the same brilliance it always has, but telescopes tuned to the right wavelengths tell another story. They reveal faint glows around magnetic regions, loops of plasma holding their shape with unusual rigidity, or filaments stretched thin and taut. Nothing dramatic has happened yet, but beneath the surface, magnetic fields are winding tighter, energy storing quietly in ways human eyes cannot see. It is a paradoxical time. Nothing appears to move quickly, yet everything is preparing. Plasma drifts along magnetic boundaries like leaves on a pond, circling without leaving their place. Charged particles hum with restrained energy, contained by fields that bend but do not yet break. The sun is not asleep, it is waiting. Scientists studying these intervals often speak of precursors, signals that suggest a flare may soon erupt, a filament darkening, a magnetic field twisting just a little more sharply, an arch of plasma flickering with increased brightness. None of these alone guarantees an explosion, but together they suggest a system reaching its threshold. Like a bowstring pulled further and further back, the tension builds quietly, almost invisibly, until release becomes inevitable. What is striking is the silence. A flare itself is sudden, bright, impossible to miss with the right instruments. But the moments before are subdued. No roar, no crack, no warning the human senses can detect. Only the stillness of patterns drawn tight, the weight of potential energy pressing against its own limits. It is the calm before fire. There is something deeply human in this image. In our own lives too, change is often preceded by quiet. A conversation pauses before a revelation. A moment of stillness comes before an outburst of emotion. Entire histories shift, not with noise first, but with silence, with the subtle rearrangement of forces unseen. The sun mirrors this rhythm on a cosmic scale. While you settle into the rhythm of the story, let yourself rest in that stillness. Picture yourself standing on the edge of a vast plain, the air unmoving, the sky too calm. You know something will happen, though you do not know when. The waiting is not empty, it is full of invisible weight. The sun carries that same weight before a flare, its silence heavy with tension waiting to be undone. There comes a point when balance can no longer hold. For days, weeks, sometimes even months, magnetic fields on the sun have been winding tighter, plasma has been stretched and strained, and energy has been pressed into invisible knots. All the while, the surface has carried itself with deceptive calm. But no system can hold infinite tension. Sooner or later, the quiet must give way. The birth of a solar flare begins in that instant of collapse. Magnetic lines, twisted beyond stability, snap into new shapes. Their stored energy, held patiently for so long, is unleashed in a surge that cascades outward. What was once hidden becomes radiant. In seconds, plasma is hurled across the solar atmosphere, light floods space, and the sun's silence breaks into brilliance. It is a threshold moment, the difference between almost and now. Before the flare, the sun seemed restrained, its fields locked in position, its plasma confined. After the flare, nothing is the same. Energy has been redistributed, structures rearranged, particles accelerated to extraordinary speeds. A single event has transformed the landscape of the star's atmosphere. From Earth, with the right instruments, this moment is dazzling. X-rays spike, ultraviolet light surges, charged particles begin their journey outward. Satellites record bursts of radiation. Telescopes trace loops of plasma expanding into space. Yet all of this grandeur begins in a split second, the narrow passage between stability and release. There is a profound rhythm in this pattern. The waiting builds slowly, quietly, layer by layer. The release comes suddenly, overwhelmingly, all at once. It is not unlike an avalanche that begins with a single shift of snow, or a dam that bursts after years of pressure against its walls. The system endures as long as it can, and then, in one decisive moment, it yields. What makes solar flares so remarkable is not just their violence but their contrast. Out of silence, brilliance. Out of hidden structure, visible power. Out of patience, sudden transformation. The sun does not shout often, but when it does, its voice carries across space, changing conditions on Earth and beyond. Imagine that moment, not as chaos but as release. The magnetic fields have been wound and tangled for so long, their tension invisible yet unrelenting. Now they let go. Energy races outward, bright and unstoppable. But in that release, there is also balance. The system finds a new shape, a new stability, even as it sends its influence far beyond its surface. This is how the universe often works. Thresholds exist everywhere, points where what has been building quietly shifts into something irreversible. A star does it in the form of flares. A life does it in moments of decision, of change, of realization. The balance collapses, and what was hidden becomes visible. If sleep reaches you now, let it come like that release, sudden, complete, transformative. The waiting is over, the silence gives way, and the flare is born. You rest, while above you, the sun's thresholds continue, timeless and endless, fireworks unfolding in the dark. When a flare erupts, the first thing to escape is light, not the gentle glow of dawn or the steady warmth that nurtures life on Earth, but a torrent of brilliance released in every direction. In an instant, radiation spans the electromagnetic spectrum, from radio waves to gamma rays, each carrying the signature of sudden release. It is as though the sun has struck a match that burns across the entire canvas of space, all at once. What makes this burst so extraordinary is its speed. Unlike the particles that follow later, slower, heavier, delayed, the light races outward without hesitation. Photons move at the universe's ultimate limit, the speed of light, crossing the gulf between sun and Earth in just over 8 minutes. Energy that was hidden moments before is suddenly everywhere, flooding space with silent brilliance. To instruments tuned to measure these signals, the flare announces itself in sharp spikes. X-rays rise steeply, radio emissions surge, ultraviolet light intensifies. Each type of radiation tells a different part of the story. The heating of plasma, the breaking of magnetic lines, the acceleration of particles. To human senses, unassisted, the event is invisible. We cannot see X-rays or feel gamma rays, but the Earth's atmosphere trembles under their arrival, responding in ways that scientists can measure. It is tempting to think of this light as destructive, and indeed, it can be. Strong flares can disrupt radio communications, disturb satellites, and alter the delicate balance of ionized gases high in Earth's skies. Yet there is also beauty in the concept. Energy once trapped in tangled magnetic fields is suddenly free, rushing across space at unimaginable speed, carrying with it the memory of the sun's inner tensions. Picture yourself standing at a great distance, watching this unfold, not with eyes but with understanding. A region of the sun flares, and instantly its message of light is everywhere. There is no hesitation, no gradual unfolding. The radiance is total, complete, simultaneous. It is not a whisper but a flood, not a single note but an orchestra of wavelengths playing at once. The contrast with the waiting is profound. Before the flare, tension builds slowly, fields winding quietly for days or weeks. Then, in a heartbeat, the light is free. All the preparation, all the hidden strain, is made visible in an instant. The sun reveals its restlessness, and for a brief span, its surface becomes a beacon brighter than usual, shouting its presence across the solar system. As you follow this thought, let the image soften in your mind. A burst of radiance does not linger forever. It shines suddenly, overwhelms its surroundings, and then fades back into the steady glow of the sun's constant light. The memory remains, but the brilliance passes. In this, the flare resembles many moments of life, sudden surges that transform the landscape, then fold back into quiet, leaving echoes that last long after the light itself has faded. The sun will flare again, and its light will race outward at the speed of thought, but tonight you rest, carried gently by the memory of its brilliance. When a solar flare erupts, it does not always scatter its energy outward in chaotic streams. Sometimes, the magnetic fields that shape the sun's surface guide the plasma into elegant forms, arches of light and fire stretching high above the photosphere, tracing invisible lines across the sky of the star. These are coronal loops, bridges of plasma lifted into space and then drawn back, suspended not by gravity but by magnetic force. Seen through telescopes sensitive to extreme ultraviolet light, the sight is astonishing. Great arcs rise from the sun's surface, glowing with the heat of millions of degrees. Some are small, no larger than Earth, while others span distances vast enough to dwarf entire planets. They curve gracefully, yet their substance is violent, streams of charged particles following magnetic highways from one footpoint to another. What makes these loops possible is the strange obedience of plasma. On Earth, fluids move as they please, shaped only by gravity or pressure. But in the sun's atmosphere, plasma follows magnetic fields with near total devotion. The fields bend and twist, and plasma moves accordingly, flowing like fire made into a river, outlining invisible patterns in blazing arcs. These structures are temporary. A loop may last minutes, hours, sometimes days, before collapsing or rearranging. As it cools, plasma drains downward, falling back toward the surface in glowing cascades. Then, as new magnetic tensions build, fresh loops rise again, forming bridges across emptiness, as if the sun were sketching shapes in fire, erasing them and drawing them anew. The loops are not just beautiful, they are clues. They tell scientists where the sun's magnetic fields are strongest, where energy is stored, and where future eruptions may occur. By studying their size, shape, and brightness, researchers learn how magnetic energy moves and transforms, offering insight into the larger puzzle of space weather. Yet beyond their science, loops carry a kind of poetry. Consider a world where fire is not bound to wood or air, but can be lifted into the sky and suspended, glowing without falling. Consider arches of flame large enough to shelter a planet beneath them, bridges made not of stone or steel but of radiant plasma, curved and fleeting. This is what the sun creates daily, unseen by our eyes but revealed by instruments that extend our vision. There is also tension in their grace. Loops hold immense energy, contained but never at peace. At times, they collapse suddenly, triggering further flares or eruptions. What looks delicate from afar is, in truth, a balance of forces that can change in an instant. Beauty and danger entwined, fire shaped into form, order hovering just above chaos. As you rest tonight, let the image linger, arches of radiant plasma, glowing silently in the void above the sun's surface, rising and falling like breaths too vast to consider. They are the sun's own handwriting across its sky, temporary bridges that flare, fade, and vanish. And if sleep comes now, let it arrive like those loops themselves, rising gently, curving into stillness, then dissolving into quiet, leaving only the trace of something magnificent that has passed. A flare does not only shine with sudden brilliance, nor shape itself into radiant loops. It also hurls matter outward, electrons and protons accelerated to extraordinary speeds, streams of charged particles spilling into the vastness of space. These storms are less visible than the burst of light, yet their effects stretch across the solar system, touching planets, spacecraft, and sometimes even Earth itself. In the moments after magnetic fields reconnect, the surrounding plasma is not left untouched. Instead, particles are flung outward, carried along invisible currents at speeds approaching that of light. They are not gentle breezes. They are torrents of energy, unseen but powerful, like winds made of matter, racing ahead to announce that the sun has stirred. Unlike photons, which arrive at Earth in just over 8 minutes, these storms take longer. Some rush forward within minutes, while others take hours or days to cross the 93 million miles. As they travel, they spread, filling broad swaths of space, washing over everything in their path. Spacecraft in orbit detect their arrival as sudden showers of high-energy particles. Astronauts behind thin shielding know them as silent hazards, reminders of how fragile human presence is beyond Earth's protective atmosphere. To the human eye, these storms are invisible, There are no streaks across the night sky to mark their passage, no roar to signal their approach. Yet the Earth's magnetic field and atmosphere feel their presence. Instruments on satellites register spikes of radiation, power systems sometimes falter, and radio signals bend or vanish in their wake. What was invisible becomes unmistakable in its consequences. These storms are part of what scientists call space weather, the changing conditions in near-Earth space driven by the Sunday. Just as the atmosphere of our planet shapes storms of air and rain, the sun shapes storms of particles that move through the void. Unlike clouds and winds, these storms are silent, weightless, and relentless, unfolding across millions of miles. What makes them extraordinary is the energy each particle carries. A single proton, accelerated by a flare, can strike with the force of subatomic lightning. Multiply that by billions upon billions, and the scale of the storm becomes clear. They may not burn the eye like a flare's radiance, but they deliver their own kind of fire, one that seeps quietly into the systems we depend on. And yet, there is wonder here too. These storms are carriers of information. By studying their composition, scientists learn about the processes at the sun's surface, about the magnetic knots that launch them, and about the conditions of interplanetary space. They are messages in particle form, letters written in protons and electrons, delivered across the solar system by invisible winds. As you drift tonight, picture those winds flowing silently through space. Not air, not water, but streams of particles, each one a fragment of the sun's unrest. They rush outward, unseen, moving faster than thought, spreading far beyond our world. You do not feel them on your skin, yet they pass by, surrounding Earth in currents we rarely notice. When a solar flare ignites, it speaks in many voices. Some are visible, like the arcs of plasma that rise above the surface. Others are felt as storms of particles rushing into space. But one of the clearest voices, the one scientists listen to most intently, is invisible to us. It is the sudden surge of X-rays, radiation that the human eye cannot see, but which instruments detect as sharp, unmistakable signatures of violence. X-rays belong to the higher energy end of the electromagnetic spectrum, beyond ultraviolet, beyond what our eyes can register. They are photons carrying more energy than visible light, capable of cutting through materials that block ordinary radiation. On Earth, we use them to see through skin into bone. In space, they reveal the hidden eruptions of the sun, broadcasting signals of events too powerful to remain silent. During a flare, the sun brightens dramatically in X-rays. Instruments in orbit, such as the GOES satellites, record sudden spikes, measuring the intensity and classifying the flare by its X-ray brightness. These classifications, from modest class to immense X-class flares, are not merely labels. They are indicators of scale, of how much energy was stored, how much was unleashed, and how far-reaching the consequences may be. What is remarkable is the contrast between visibility and invisibility. To human eyes, the sun looks the same during a flare. Its blinding glow overwhelms any detail. Yet, to an X-ray detector, the event is unmistakable, a sharp climb in radiation that unfolds over minutes and then slowly declines. The star is speaking in a frequency we cannot hear, and only with the right instruments can we understand its message. These bursts of X-rays ripple outward, striking Earth's atmosphere in less than 10 minutes. They ionize gases high above, altering the delicate layers that bend and reflect radio waves. Pilots, navigators, and operators of communication systems may notice sudden blackouts, signals lost without warning. The sun does not need to strike directly with particles or winds. Its radiation alone can reach across space and touch our technologies. And yet, for all their disruptive potential, these X-rays are also guides. They give scientists a way to study the dynamics of flares in real time. By measuring the rise and fall of X-ray intensity, researchers trace the processes unfolding in the sun's atmosphere, learning how magnetic reconnection releases energy, how plasma heats to tens of millions of degrees, and how that energy radiates outward. Think of it as a hidden language, one that speaks not in words or sounds but in sudden pulses of radiation. The sun does not announce its flares with thunder or lightning. It whispers in X-rays, subtle to human senses but loud to machines built to listen. As you settle into rest, imagine those unseen signals spreading through space. They travel at the speed of light, invisible yet powerful, carrying the record of a flare's eruption. You do not see them, you do not feel them, but they pass by, a quiet reminder that the universe is filled with voices beyond the reach of our eyes. Let it come like those X-rays, swift, silent, unperceived, yet carrying immense weight, moving through you gently as the story of the sun continues above. When you think of an explosion, perhaps you think of noise first. The crack of thunder, the roar of fire, the shock wave that rattles the ground. On Earth, energy is almost always accompanied by sound, carried through air or water to our ears. But in space, there is no air, no medium for sound to travel. And so when the sun unleashes a flare, an explosion vast beyond measure, it unfolds in perfect silence. The violence is real. Magnetic fields snap and realign, releasing energy equivalent to billions of nuclear bombs. Plasma is hurled upward in blazing arcs, particles are flung outward at astonishing speeds, and radiation floods space instantly. But if you were close enough to witness it, protected somehow from the heat and the radiation, you would hear nothing. The sun roars with light, but never with sound. This absence is not emptiness, it is simply the nature of space. Sound requires vibration of matter, a medium to carry its waves. On Earth, air trembles when thunder rolls, and our ears translate that trembling into noise. In the vacuum of space, nothing trembles in that way. Energy travels as light, as particles, as magnetic fields, but not as audible sound. The sun's fury is unaccompanied by any cry. There is a strange poetry in this. The greatest explosions in the solar system pass in silence, visible only in light and in their effects on distant worlds. What we think of as noise, as the sign of force, is absent. Instead, there is brilliance, white-hot, overwhelming, pouring outward into a silence so vast it cannot be broken. Scientists have sometimes translated solar activity into sound by converting data into audible tones. Instruments that measure oscillations or radiation can map their rhythms into frequencies we can hear. The result is eerie, a kind of cosmic music, drawn not from air but from patterns of plasma and light. It is not the sun's natural voice, but a human translation, an attempt to bridge the gap between silence and sound. Still, the truth remains. A solar flare is an explosion beyond imagination, yet it produces no audible thunder. If you were near it, you would see brightness, feel radiation, and be struck by particles, but your ears would hear only stillness. The absence is almost unsettling, as though the universe were reminding us that our senses capture only a small part of reality. There is a lesson in this silence. Not every force declares itself in ways we expect. Some of the most powerful changes happen without noise, without announcement. A star can reshape its atmosphere without a sound. A life, too, can shift in silence, decisions made quietly, thresholds crossed without fanfare, moments that transform everything though no one hears them. As the universe turns above you, let that image stay with you, an explosion vast and unstoppable, unfolding in perfect quiet. Picture the sun's surface blooming with light, magnetic fields tearing and reconnecting, plasma rising like fire, but all of it passing without a sound. Across the surface of the sun, delicate structures sometimes appear, long, thread-like streams of plasma suspended above the photosphere, held aloft by magnetic fields. To the eye of a telescope, they look like strands drawn across the face of the star, dark against its bright background. These are filaments, fragile bridges of glowing matter that seem too fine, too graceful, to belong to a star of such violence. A filament can stretch for hundreds of thousands of kilometers, longer than the distance between Earth and the Moon. Yet despite their size, they appear almost weightless, thin lines floating above the surface. What holds them there is not gravity but magnetism, arcs of invisible force that support plasma in configurations that defy intuition. They hover like threads of silk across the sun's blazing body, delicate and temporary. The illusion of delicacy is deceptive. Each filament contains vast amounts of plasma, hot and heavy, suspended precariously. For hours or days it may hold, tracing an elegant curve across the sun's disk. But the balance is never permanent. Sooner or later, the forces that sustain it shift, and the filament collapses. In that instant, grace gives way to violence. The plasma falls or erupts outward, releasing energy that flares brilliantly across space. From Earth, these collapses are invisible to the naked eye. To instruments, however, they are dazzling. A filament that seemed calm only moments before can become the trigger for a solar eruption, releasing energy equivalent to millions of nuclear detonations. What looked fragile proves to be a reservoir of hidden power, its fall setting off a chain of light and motion. Scientists study filaments carefully, not only for their beauty but for their potential to signal larger events. Their presence often coincides with regions of complex magnetic activity, areas where flares and coronal mass ejections are more likely to occur. A filament is both a wonder and a warning, an elegant sign that tension is building, that energy is waiting to be freed. There is something haunting about their dual nature. They look like threads spun across the face of a star, soft and almost decorative, yet within them lies the power to reshape space weather across the solar system. They embody both fragility and strength, balance and collapse, a dance poised always at the edge of transformation. While the stars keep their silent watch, imagine those filaments drifting above the sun's surface. Not flames, not rigid beams, but flowing strands, quiet and suspended. They curve and shimmer in silence, carrying within them immense energy, waiting for the moment when the balance tips. If sleep comes now, let it arrive as softly as those threads hang in space, weightless, suspended, fragile yet serene. And if your dreams shift suddenly, let them echo the filament's collapse, a moment of brilliance unfolding within the stillness. Above you, the sun's filaments continue their dance, delicate strands across a star's burning face, holding for a time, then falling into light. High above Earth, where the atmosphere fades into space, machines circle silently. They do not breathe, they do not sleep, but they watch. Among their many tasks, tracking storms, guiding navigation, transmitting voices across oceans, some have a singular purpose: to keep their gaze fixed on the Sunday. These satellites are our sentinels, guardians that record the flares and storms we cannot see from the ground. From their vantage points, satellites escape the shielding effect of Earth's atmosphere. On the surface, our sky blocks much of the sun's high-energy radiation, protecting us but also blinding us to its subtler signals. In orbit, however, detectors are exposed to the full spectrum: X-rays, ultraviolet, charged particles, all arriving unfiltered. Every burst of radiation, every sudden flare, leaves its mark on their instruments. Some satellites, like the GOES series, measure X-ray intensity to classify flares. Others, like SOHO and SDO, capture detailed images of the sun's surface and atmosphere, recording loops of plasma, collapsing filaments, and the faint glow of magnetic structures. Together, they create a continuous portrait of the star, a record no human eye could make. These machines are more than passive observers. Their data becomes warning systems, alerts sent across the globe to tell pilots, engineers, and power grid operators that the sun has stirred. A spike in X-rays, a surge in solar wind, a storm of particles racing toward Earth. Satellites are the first to know, and their signals ripple quickly into human systems of preparation. There is something quietly profound about this. For thousands of years, people studied the sun from the ground, watching sunspots with simple lenses or recording auroras as omens in the night sky. Now, in the modern age, we place mechanical eyes in orbit, asking them to keep constant watch. They orbit tirelessly, unblinking, bearing witness on our behalf. From a poetic view, satellites are like scribes in space, writing down the sun's moods in streams of numbers and images. They translate the silent language of radiation into patterns we can read. They do not know the meaning of what they see, but we do. They are instruments of perception, extensions of our curiosity, reminders that even from a distance of millions of kilometers, we want to understand the star that sustains us. Yet even these machines are vulnerable. A strong enough flare can damage their circuits, scramble their sensors, or shorten their lifespans. They are both watchers and targets, studying storms that may one day strike them directly. Their presence near Earth is both a strength and a risk, a fragile bridge of technology facing the same forces it was built to measure. While the stars keep their silent watch, picture them drifting in orbit, quiet, metallic, sunlit on one side, shadowed on the other. They do not feel, but they see. They record every burst, every surge, every flicker of unrest from the Sunday. While you rest, the satellites keep watch, silent witnesses to the fireworks of the star that lights your every day. When the sun releases a storm, its journey does not end in the void. Some of that energy finds Earth, carried on streams of charged particles that collide with our planet's magnetic field. Instead of striking the surface directly, the particles are guided toward the poles, funneled downward along invisible lines. There, high in the atmosphere, they meet atoms of oxygen and nitrogen, and in those collisions, night skies bloom with color. Auroras are the Earth's reply to the sun's flare, an echo painted not in sound but in light. Curtains of green shimmer first, the most common color, created by oxygen glowing softly at high altitude. Sometimes red mingles above the green, or purples and blues ripple along the edges, each hue the result of a different interaction, a different altitude, a different kind of collision. Together they weave skies into living tapestries, waves of color flowing and folding in silence. To those who stand beneath them, auroras are more than light. They are motion, shapes that shift and dissolve as if the heavens themselves were breathing. A single curtain may stretch across the horizon, then ripple like fabric caught in an unseen wind. At other times, spirals and arcs race overhead, dancing in patterns too complex to predict. No two auroras are the same, for each is born from a unique meeting of solar particles and Earth's magnetic shield. For centuries, people who lived in polar regions looked up at these lights and filled them with meaning. Some saw spirits moving across the sky. Others believed they were messages from ancestors, or signs of battles being fought beyond the clouds. The scientific explanation came later, but the sense of wonder remains. Even now, with instruments explaining the physics, standing beneath an aurora feels like standing at the threshold of mystery. What is remarkable is how far the sun's influence travels. A flare erupts millions of kilometers away, and days later, its particles turn the quiet darkness of Earth's night into radiant color. Violence on the surface of a star becomes beauty in our skies. What might disrupt satellites and power lines is also capable of creating spectacles that move us into silence. From orbit, satellites capture the auroras as glowing ovals around the poles, vast enough to cover continents. From the ground, they are intimate, personal, overwhelming. To watch them is to feel both small and connected, to sense the chain linking Earth to the sun, space to sky, science to wonder. While light travels across unimaginable distances, see yourself lying beneath those shifting lights. The air is crisp, the horizon wide, the sky above alive with flowing colors. You feel no danger, only awe. The sun has spoken, and Earth has answered, painting the darkness with light. While you drift, the skies above the poles may still be glowing, curtains of green and red billowing in silence, the flares echo painted in night. Not every solar flare is equal. Some are brief sparks, small disturbances barely noticed by Earth. Others rise into history, recorded not just by instruments but by their consequences. Giants among storms, each one remembered as a landmark in our attempt to understand the Sunday. These flares are not measured only in brightness, but in impact, leaving echoes that stretch far beyond their moment of release. One of the earliest and most famous came in 1859, known now as the Carrington event. On a September morning, astronomer Richard Carrington traced a sudden flash of light on the sun's surface, visible even through his telescope. Hours later, Earth felt its consequences. Telegraph wires sparked, operators were shocked, and some systems caught fire, as if struck by lightning from a clear sky. Auroras spread so far south that people in the Caribbean saw night skies alight with color. It was the first time humanity realized how deeply a solar storm could reach into our own world. Since then, instruments have built a record. a catalogue of the sun's greatest flares. In 1972, during a period of heightened solar activity, an immense storm disrupted communications and even triggered naval mines near Vietnam. In March 1989, a powerful flare and its associated storm collapsed an entire power grid in Quebec, leaving millions in darkness within seconds. These were reminders that the sun, though distant, could touch human infrastructure with startling immediacy. More recently, modern satellites have measured flares of extraordinary strength. In 2003, a series of massive events, sometimes called the Halloween storms, produced flares so intense that some instruments were briefly blinded, unable to record their full magnitude. These giants disrupted airline routes, damaged satellites, and once again painted auroras far beyond their usual homes. Scientists estimated their power to be among the largest ever measured in the modern era. Each of these giants serves as both warning and teacher. They remind us that the sun's calm glow hides the potential for sudden transformation. They also provide data, clues about magnetic fields, plasma motions, and the processes that trigger eruptions. By studying their fingerprints, scientists refine their models, hoping to anticipate the next great event. And yet, even our greatest records are only a fragment of the sun's history. The Carrington event was dramatic, but it may not have been the largest the sun has ever produced. Traces in tree rings and ice cores suggest that even more powerful storms struck Earth centuries ago, long before satellites or telegraphs existed to record them. Humanity may have witnessed skies ablaze without understanding their source, or without explanation. As you rest tonight, see those giants not as threats, but as reminders of scale. The sun has moods that dwarf our technology, cycles that stretch beyond our lifetimes, events that shake Earth yet pass unnoticed in the rhythm of the cosmos. Each flare, small or great, is part of the same story, energy stored, released, and carried outward. And if sleep gathers around you now, let it arrive like those historical echoes, long remembered, gently fading, woven into the vast catalogue of time. The giants remain, not to frighten, but to remind us of the connection between our fragile world and the star that sustains it. To call a solar flare destructive is true, but incomplete. Yes, it can disrupt satellites, black out power grids, confuse radio signals, and endanger astronauts. It is a force that can bend human systems with a single burst of energy. Yet when scientists and skywatchers describe them, they often use another word just as freely: beautiful. This is the paradox of the sun's eruptions. They are both peril and wonder, threat and spectacle, destruction and art. Seen through the eyes of specialized telescopes, flares bloom across the sun in cascades of color. Ultraviolet images reveal ribbons of glowing plasma curling upward, while X-ray detectors capture regions blazing with sudden intensity. Loops arch into space like luminous bridges, filaments collapse in radiant falls, and entire regions brighten in seconds. What would damage our machines becomes, at a distance, a vision of order and elegance, as though chaos has been sculpted into light. It is easy to forget that beauty often lives in the same places as danger. Lightning storms terrify but also awe with their brilliance. Volcanoes devastate landscapes, yet leave behind eruptions of color and shape that capture imagination. The northern lights, themselves born of solar storms, ripple across the sky as one of the most enchanting sights on Earth, even though their cause is the arrival of hazardous radiation. Solar flares belong to this family of contradictions, forces we respect and fear, yet cannot help but admire. What makes flares uniquely compelling is their transience. They arrive suddenly, lasting minutes or hours, then fade back into the sun's steady glow. To observe one is to witness a performance that cannot be repeated in exactly the same way. Each flare has its own structure, its own rhythm of light and motion, its own place in the catalogue of solar memory. Their beauty is not staged for us, yet we find ourselves drawn to it, compelled to watch. For scientists, the beauty lies not only in appearance but in understanding. To trace the physics behind a flare, the twisted magnetic lines, the acceleration of particles, the radiation spread across space, is to glimpse the order hidden in apparent chaos. Complexity resolves into clarity, the mathematics of plasma and magnetism painting the same arcs that telescopes reveal. In that clarity is a kind of aesthetic, the elegance of nature's laws made visible. For the rest of us, beauty comes more simply. It is in the photographs, the glowing loops captured in false colors, the auroras that follow days later, the knowledge that the sun above us is alive, dynamic, unpredictable. It is the reminder that what sustains life can also endanger it, and that both truths coexist within a single star. As your breathing finds an easy pace, let that duality rest with you. That beauty and danger are not opposites but companions. The flare that can darken cities also paints skies. The same explosion that scrambles satellites creates visions of light too grand to imagine. The sun teaches us that awe often grows in the same soil as fear. And if sleep finds you now, let it come like the fading of a flare, brilliant for a moment, then soft, then gone, leaving only the quiet glow of memory. The beauty remains, the danger passes, and the star continues its eternal rhythm, a balance of wonder and fire. On a September morning in 1859, the sun sent a message to Earth unlike any it had delivered before, at least in human memory. Astronomer Richard Carrington, observing the star through his telescope, recorded a sudden flash of white light on the sun's surface. He could not have known, in that moment, that the flare he had just witnessed would ripple across the world, setting wires ablaze and sparking the first great lesson in space weather's power over human invention. Hours later, the storm arrived. Charged particles carried outward by the sun crashed into Earth's magnetic field, distorting it violently. Currents raced along the very wires that humans had so recently strung across continents. Telegraph systems, the backbone of communication in the mid-19th century, erupted with sparks. Operators were shocked by their own instruments. In some cases, fires ignited at their stations, metal glowing from the surge of energy. And yet, even amid the danger, wonder appeared. With telegraph batteries disconnected, some systems continued to function, powered not by their own design but by the storm itself. Messages leapt across lines on currents born of solar fury. The sun had, for a brief time, become the world's telegraph operator. Meanwhile, the skies told their own story. Auroras glowed not only in northern latitudes but across the globe, painting night skies in places unaccustomed to such displays. Reports from the Caribbean spoke of people reading newspapers at midnight by the light of shimmering curtains above. What had been a phenomenon of the far north became, for one night, a spectacle shared almost everywhere. The Carrington event, as it came to be known, marked the beginning of humanity's awareness that the sun could reach into our technologies. Before this moment, storms of plasma and light had touched Earth only in their skies, inspiring myths and awe. But now, with wires stretched across continents, the sun's storms could spark fires, disrupt systems, and remind humanity that its inventions were not immune to the wider forces of the cosmos. Looking back, the story feels almost symbolic. The telegraph was the first global communication network, fragile wires connecting towns and nations. And just as the world began to weave itself together with electricity, the sun reminded us that its own currents, far greater and older, could intrude without warning. The lesson was simple but profound. In building our networks, we had tied ourselves more tightly to the moods of the star that sustains us. Today, scientists still look to the Carrington event as a warning. Modern satellites, power grids, and communication systems are far more complex and far more vulnerable than the telegraphs of 1859. If such a storm were to strike now, its effects could be vast, rippling across technologies we depend on every hour. Yet it is also a reminder of continuity. The sun has always been restless. It is our awareness, our connection, that has changed. As your attention lingers on these images, think of those telegraph wires glowing with unexpected fire, messages traveling without batteries, skies alive with color. The sun had spoken directly, and Earth, for the first time, heard its voice in our machines. The storm fades, the wires cool, but the memory remains, a spark in history carried forward into every dawn. In our modern world, silence does not usually mean peace. A darkened city, a phone that will not connect, a radio suddenly cut to static. These kinds of silences signal absence, a missing thread in the vast networks that tie us together. When solar storms touch Earth, they sometimes bring this kind of silence, blackouts that remind us how delicate our web of electricity and communication truly is. Power grids are extraordinary achievements. With a flick of a switch, current flows across thousands of kilometers, bringing light to homes, warmth to buildings, and energy to machines. Yet these grids are also vulnerable. A strong solar storm can disturb Earth's magnetic field, inducing currents in long transmission lines. Transformers, designed to guide power with precision, can suddenly find themselves carrying surges far beyond their limits. The result may be overheating, failure, or collapse. In March 1989, Quebec experienced this fragility firsthand. A geomagnetic storm struck, and in less than 2 minutes the province's power grid fell silent. Millions of people were left in darkness, not because of human error or lack of supply, but because the sun had disturbed the delicate balance of current flowing through metal and wire. Across the globe, satellites registered disruptions, and radio operators struggled to keep connections alive. Silence spread in ripples, echoing through machines that depend on steady flow. The quiet of a blackout is profound. Streets once filled with neon signs or humming with electricity become still. Factories pause, homes light candles. The absence of power reshapes life instantly, reminding us that beneath our apparent control lies dependency. For all our engineering, our systems are tied to a star that can disrupt them with a single storm. And yet, this silence carries lessons. Scientists use these events to refine models, to design better shielding, to strengthen the resilience of grids and satellites. Engineers plan for storms, learning from each failure how to withstand the next. The memory of darkness becomes a guide for preventing future collapses. There is also a quiet reflection to be found here. In a world so saturated with constant light and sound, blackouts can feel both unsettling and strangely calming. The hum of machines fades, and for a moment, people look upward, seeing the stars as they once did before electricity. During the Quebec blackout, skies cleared of light pollution revealed auroras shimmering overhead, as if the very cause of the silence had painted the heavens in return. The paradox is clear. The same storm that silences our systems also offers beauty, reminding us that the sun is both creator and disruptor, giver of energy and taker of stability. Its storms strip away our illusions of permanence, showing how thin the line is between lighted abundance and fragile stillness. As you rest tonight, picture that silence, not as threat, but as pause. A city darkened, stars revealed, networks temporarily quiet. The sun has brushed against our systems, and for a time, we are reminded of dependence. If you are about to fall asleep, let it arrive like that blackout. Sudden stillness, deep quiet, not frightening, but restful. The power will return, the grids will hum again, but for now there is only silence, soft and complete. For most of us, solar storms are distant events. We may see their echoes in auroras or read about disruptions to satellites and grids, but for astronauts, the sun's fury is not abstract. Beyond Earth's magnetic shield, the radiation from a flare is not softened or deflected. It arrives directly, a storm of charged particles sweeping across space. And when that storm comes, astronauts must seek refuge, hiding behind the thin walls of their craft. Spacecraft are built with many protections, but they are not fortresses. A flare can release particles so energetic that ordinary shielding is not enough. Engineers design storm shelters within spacecraft, small, reinforced compartments where astronauts can retreat during major solar events. In those moments, exploration pauses. The work of science, the view of Earth through the window, the routine of orbit, all are set aside. What matters is waiting out the storm in silence. Inside such a shelter, the world narrows. The vastness of space outside, the beauty of Earth below, are replaced by closeness, by containment. Astronauts wait, monitoring systems, listening for updates from Earth, knowing that beyond the walls particles are racing by with invisible force. It is a reminder of how thin the barrier is between human life and the openness of space, how fragile the line that allows us to step beyond our planet. There is a certain irony in this hiding. Humanity looks to the stars as a symbol of freedom, of expansion, of discovery. Yet in moments of solar unrest, astronauts must retreat into spaces smaller than a room, relying on layers of shielding and the passage of time. Exploration yields to survival. The cosmos, for a while, demands patience. History has offered warnings. During the Apollo missions, astronauts crossed the dangerous gap between Earth and Moon without incident, but had a major flare erupted during those journeys. The consequences could have been severe. Later missions have carried detectors to measure radiation levels, giving more warning and more options for shelter. Still, the truth remains. Spacefarers live at the mercy of the sun, every mission tied to its moods. And yet, astronauts describe these experiences without bitterness. They understand the risk, and within that risk lies meaning. To hide is not failure, it is resilience, a strategy to endure and to continue. Each flare survived, each storm weathered, is a step toward deeper exploration, a reminder that humanity's reach must grow carefully, in respect to forces greater than ourselves. There is also something profoundly human in that hiding. On Earth, too, storms drive us to shelter. We wait them out in houses, in caves, in safe places, listening to winds or thunder pass by. In space, the principle is the same. Though the storm is invisible, the silence total, the scale cosmic. While you rest in your own stillness, imagine those astronauts tucked away behind walls, waiting quietly for the storm to pass. Outside, particles rage unseen. Inside, there is calm, patience, endurance. The sun does not simply warm the earth. Its moods leave subtle signatures across centuries, woven into the rhythms of weather, growth, and even the chemistry of ice. While a single solar flare may pass quickly, the cycles of solar activity, years of rising and falling intensity, whisper their influence into our planet's climate. These whispers are quiet, often drowned out by the louder forces of oceans, atmosphere, and human activity. But if you know where to look, you can find their traces. In polar ice, layers build year by year, each preserving tiny samples of the atmosphere as it was when snow first settled. Within those layers lie records of cosmic rays, energetic particles from beyond the solar system that strike Earth's atmosphere. When the sun is active, its magnetic field shields us more strongly, reducing the number of cosmic rays that reach the surface. When it is quiet, more arrive. The chemistry of the ice reflects this balance, creating a long, silent record of the sun's cycles locked in frozen time. Tree rings tell a similar story. Each year, as trees grow, they add a new layer of wood. Subtle changes in the amount of carbon-14, an isotope created when cosmic rays strike the atmosphere, leave their imprint in those rings. Scientists, studying them centuries later, can trace the rhythms of solar activity, the rise and fall of cycles, written into the wood of forests that lived long before telescopes existed. These natural archives reveal moments when the sun fell into unusual quiet, such as the Maunder minimum in the 17th century, when sunspots nearly vanished for decades. During that time, parts of Earth experienced colder winters, rivers freezing more deeply, seasons shifting subtly. While climate is shaped by many forces, the sun's variations left their faint marks, layered into history like soft background notes in a much larger symphony. What is striking is how gentle these influences are. The sun does not dictate Earth's weather in sudden commands. Instead, it nudges, whispering through radiation and magnetism, altering patterns slightly, creating ripples that spread through ecosystems and skies. Over centuries, those ripples accumulate, enough for scientists to read their stories in ice and trees, in sediments and archives of stone. There is humility in this discovery. We often think of the sun as a constant, a reliable star rising each day unchanged. Yet even its small shifts can echo across our world, recorded faithfully in natural memory. The Earth, in its ice sheets and forests, listens carefully to the sun, storing its voice across centuries for us to hear long after the cycles have passed. As you rest tonight, Imagine those whispers carried through time, snow falling in silence, carrying with it the chemistry of the sky, a tree adding a thin ring of growth, its wood inscribed with signals from above. None of these processes rush. They are patient, steady, leaving traces that speak softly but clearly to those who learn how to listen. And if sleep comes to you now, let it arrive like those records, quiet, layered, unhurried. The sun will whisper again, and earth will continue to keep its memory, storing traces in ice, in trees, in the long unfolding of time. Long before telescopes, before satellites, before we learned the language of plasma and magnetism, people still looked upward and saw the sky transformed. Curtains of light stretched across the heavens, arcs shifting and shimmering in colors that did not belong to ordinary nights. Without instruments to measure or models to explain, these lights were woven into stories, myths, and omens. They became part of the human attempt to understand the unseen. In the far north, the auroras were often seen as spirits. Among the Sami of Scandinavia, there were tales of the lights as living beings, powerful and unpredictable, demanding respect. Some believed whistling at the aurora would draw it closer, risking danger. In Inuit traditions, the dancing lights were sometimes thought to be the souls of ancestors playing across the sky, a bridge between the living and the dead. Far from the Arctic, stories still grew. In medieval Europe, sudden red skies were often taken as omens of war or plague, signs that heaven itself was warning of turmoil. Chinese chronicles recorded fiery vapors streaking across the night, linking them to the fortunes of emperors. In Japan, shimmering arcs were interpreted as the glow of celestial foxfires, the trickster spirits said to carry their own light. Each culture, in its own way, gave the skies meaning. Lacking the language of electrons and magnetic fields, they spoke instead of gods, spirits, and destinies. The skies became a mirror for human concerns, reflecting hopes, fears, and warnings. To see light dance unexpectedly across the heavens was to feel that the universe itself was speaking, and people listened. Today, we know that these luminous skies are born of solar storms, of flares and eruptions sending particles across space to strike Earth's magnetic shield. We know the green comes from oxygen, the reds from higher altitudes, the purples from nitrogen's glow. We can model them, predict them, photograph them from orbit. Yet none of this removes their power to inspire. Even with full knowledge, to stand beneath an aurora is to feel wonder beyond explanation. There is a continuity here, between myth and science, between legend and measurement. Where once people spoke of omens, we speak of data. Yet the experience of looking upward remains much the same. Surprise, awe, a sense of being part of something vast and alive. Science explains, but does not erase, the feeling that the sky is both beautiful and mysterious. The sun, through its flares, has always shaped human imagination. Its storms, reaching across millions of kilometers, painted skies that became stories. Those stories, in turn, shaped cultures, giving meaning to events beyond human control. In every age, people found language to describe the same phenomenon, whether through spirits, omens, or physics. Perhaps this is what makes the aurora timeless. It lives at the meeting point of knowledge and wonder. We can name its cause, but we still feel its mystery. The sky, alive with fire, has always been both a warning and a gift. The sun is restless, yet its moods are not random. Patterns emerge, cycles of activity, bursts that follow the winding of magnetic fields, storms that rise and fade in rhythm. For centuries, people could only watch, surprised by each eruption. But in the modern era, we have sought something more, the ability to predict, to see the signs before the storm breaks, to turn the sun's unpredictability into fragile warnings. At the heart of this effort is observation. Satellites keep constant watch, recording X-rays, ultraviolet emissions, and the shifting geometry of sunspots. Ground-based telescopes add their own vigilance, tracing magnetic fields and plasma motion. Each stream of data is a clue, a fragment of the puzzle. Scientists weave these fragments into models, mathematical structures that try to capture the restless physics of the star. Prediction, however, is not certainty. A sunspot may look ominous, its fields twisted and dark, yet no flare follows. Another region may appear quiet, only to erupt with stunning force. The sun resists simplicity. It is too vast, too complex, its interior hidden from direct view. What we see is only the surface, the outer ripples of processes that unfold deep within. Still, progress has been made. By comparing decades of observations, scientists have learned which patterns tend to precede eruptions. Sharp magnetic gradients, fast-growing sunspot groups, sudden brightenings in ultraviolet light, all are signs that tension is building. These indicators allow warnings to be issued, sometimes hours, sometimes days before a flare or a storm of particles reaches Earth. The warnings are fragile, but they matter. Power companies can prepare grids, airlines can adjust routes, astronauts can seek shelter. The world becomes a little less vulnerable when we see the storm approaching, even if we cannot stop it. It is not unlike predicting weather on Earth, always imperfect, sometimes frustrating, but better than surprise. There is also humility in these efforts. For all our models, we remain students of the sun, listening more than commanding. We cannot control its cycles, only observe and respond. Each success in prediction is a reminder of both our progress and our limits. The sun is not tamed by our mathematics. It simply allows us glimpses into its patterns. And so, the science of prediction is less about certainty and more about readiness. It is the art of listening carefully, of translating faint signs into cautious warnings, of accepting that some storms will always surprise us. In this sense, it is a dialogue. The sun speaks in bursts of radiation, and we answer with models and forecasts, fragile but valuable. Perhaps the beauty lies not in perfect foresight, but in the attempt itself. Humanity, on its small planet, building tools to read the moods of a star. Each prediction is an act of connection, a bridge across 93 million miles, a way of saying, we are watching, we are learning, we are preparing. The modern world is stitched together by invisible threads. Satellites circle high above, carrying signals for communication and navigation. GPS guides ships, aircraft, and even the phones in our pockets. Pilots cross oceans with the aid of radio beams and satellites, while power grids on the ground hum in coordination. This web feels solid, reliable, ever-present. Yet above it all, the sun breathes, and with a single storm, it can tug at those threads until they fray. When a flare erupts, radiation arrives first. X-rays and ultraviolet light reach Earth in minutes, altering the ionosphere, the thin shell of charged particles surrounding our planet. Radio waves, which bounce off this layer to travel long distances, suddenly scatter or vanish. Pilots flying polar routes have found themselves cut off mid-flight, forced to divert because their radios fell silent. The disruption is invisible, yet immediate, turning the familiar skies uncertain. Not long after, storms of particles follow. Satellites, exposed above the safety of Earth's atmosphere, are struck directly. Electronics built with delicate precision find themselves bombarded by high-energy particles. Circuits glitch, sensors misread, memory corrupts. Some satellites recover after a reset, others are permanently scarred. Even spacecraft hardened against radiation feel the weight of these storms, as though the sun were testing the limits of their design. GPS, so central to modern life, is particularly vulnerable. A signal that must travel thousands of kilometers from satellite to receiver can be distorted by ionospheric turbulence stirred by solar storms. For a navigator at sea, or a farmer guiding automated equipment, the difference between accuracy and error may mean safety or risk, efficiency or loss. The sun's breath ripples through systems that were never built with its moods in mind. Aviation, too, finds itself on the edge. Airlines rely not only on navigation but also on constant contact with controllers. During strong solar events, high-frequency radio becomes unreliable, especially along polar routes where the effects are strongest. Flights must reroute, burning extra fuel and time, simply to keep within the boundaries of communication. The sky, usually a domain of control, bends under the influence of space weather, and yet we continue to build higher, faster, more connected. Satellites multiply, networks expand, dependence deepens. Each new step outward makes us more powerful, but also more exposed. The sun does not recognize our technologies, nor does it pause for them. Its storms sweep outward, as they always have, indifferent to the fragile scaffolding of machines that orbit our small world. This fragility does not mean helplessness. Engineers learn from each storm, designing systems that can recover quickly, shielding circuits, creating backups and redundancies. Warnings from observatories allow operators to shift satellites into safe modes or prepare grids for surges. We cannot prevent the sun's breath, but we can bend with it, absorbing the impact without breaking. The phrase "technology on the edge" is not only about risk, it is also about resilience. Our systems live at the boundary between Earth and space, thriving in an environment where danger is constant. Each flare reminds us of that edge, of how much we rely on it, and of how carefully we must guard it. The sun feels immense to us, yet in the catalogue of stars it is ordinary, neither the largest nor the smallest, neither the quietest nor the most violent. If our familiar star can unleash storms that shake satellites and paint the skies with light, what might life be like under other suns, stars whose tempers burn hotter, whose flares erupt with even greater force? Astronomers have found such stars. Red dwarfs, the most common type in our galaxy, often unleash storms far stronger than those of our Sunday. Their flares can brighten the star's surface by factors of hundreds, flooding nearby planets with radiation. For worlds in those systems, the line between day and catastrophe may be thin. Skies could ignite with constant auroras, atmospheres may be stripped away, and surfaces might be bathed in radiation levels far beyond what Earth has ever known. Think about standing on such a planet. If life were possible there, the sky would not hold quiet blue but restless color, shifting frequently with storms. A flare could rise suddenly, turning night into a false dawn, saturating the air with strange hues. Instead of rare events remembered for centuries, flares might be daily realities, shaping culture, behavior, perhaps even biology. Survival itself would require adaptation to a star that never rests. Not all alien suns are violent. Some are more stable than our own, their surfaces calm, their cycles subdued. Around such stars the skies may remain serene, auroras rare, storms distant. If life exists there, its myths might never include fiery skies or sudden bursts of light. Its sense of normal would be different, stability, not interruption. In searching for planets beyond our solar system, astronomers consider these storms carefully. A star that flares too often may strip its planets of atmospheres, leaving them barren. Yet paradoxically, some storms may help spark the chemistry of life, delivering energy that breaks molecules apart and reshapes them into the building blocks of biology. Just as lightning on Earth may have helped life begin, stellar flares elsewhere could serve as catalysts, both destructive and creative. The thought expands perspective. Our sun, with its cycles and storms, may be unusually well balanced, restless enough to stir, but calm enough to sustain. Its flares can be dangerous, but they are not constant, not overwhelming. They remind us of fragility without extinguishing it. In the gallery of stars, this balance is precious. And so, when we study other suns, we see not just variety but possibility. Worlds may exist where storms dominate every horizon, or where quiet reigns without interruption. Somewhere, there may be skies lit nightly with ribbons of color more intense than any aurora on Earth. Somewhere else, the heavens may hold nothing but steady glow. For now, these remain imaginations, guided by data, yet they tell us that the story of flares is not confined to our Sunday. Across the galaxy, stars breathe with storms, shaping planets and skies in ways both harsh and extraordinary. Every breath you take, every harvest of grain, every drop of rain owes something to the Sunday. Its steady radiation drives the winds, powers the growth of plants, and warms the oceans that cradle life. Without it, Earth would be a frozen rock, drifting silent and barren, Our dependence is complete. We do not simply live beneath the sun, we live because of it. And yet, dependence carries risk. The same star that nurtures can disrupt. Its flares, storms, and winds may not threaten the continuation of life itself, but they unsettle the systems we have built in its light. Satellites that circle Earth, grids that carry power across continents, radios that connect pilots to controllers, all rest on an assumption of stability. When the sun breathes harder than usual, that assumption wavers. It is a balance we cannot escape. To exist here is to rely on the sun's gift of energy, but also to accept the interruptions it brings. The story is not unlike a river. Its waters give life to fields and cities, yet floods reshape the very same land. Humanity learns to build with the rhythm of that river, not against it. In the same way, we are learning to live with the rhythm of solar storms. Our awareness of this duality is recent. For most of history, the sun seemed unchanging, rising with the same brightness day after day. Its storms were glimpsed only in auroras and unexplained disruptions. Today, instruments reveal its restlessness in detail, showing us how fragile our reliance is. We see clearly now that the systems binding our world together, communication, power, navigation, are tethered to a star that does not bend to our needs. The recognition is sobering, but it is also empowering. By acknowledging this balance, we gain the chance to prepare. Satellites can be shielded, grids reinforced, warnings issued. We cannot prevent a flare, but we can choose how to meet it. Dependence does not mean helplessness. It means responsibility to anticipate, adapt, and endure. There is also perspective here. Life has always lived at the edge of this balance. Long before satellites or wires, the sun's variability shaped climates, seasons, and the conditions that guided human history. Crops flourished or failed under its changing rhythms. Skies filled with auroras long before they were explained. Our dependence is not new, only our awareness has deepened. And so we find ourselves in a paradoxical relationship, utterly reliant, yet occasionally disrupted, blessed by the sun's constancy, yet reminded of its power to unsettle. To live on Earth is to live with this duality, to accept that our greatest source of stability is also a source of surprise. The balance of dependence is not a problem to solve, but a truth to live with. We draw warmth and light from the same star that sometimes blinds our machines. We thrive under its steady glow, even as we learn to shield against its storms. In this balance lies the rhythm of our existence, a reminder that to depend is not weakness, but simply the way of life beneath a star. To live beneath a star is to live in paradox. The sun is our provider, sending light that drives the winds, warms the oceans, and fuels the quiet chemistry of plants. Every heartbeat on Earth is linked, in some way, to the energy streaming outward from its core. Yet this same star carries storms, sudden flares, floods of particles, bursts of radiation that can unsettle the fragile systems we weave in its light. It is both nurturer and disturber, a presence that sustains and challenges at once. The duality is striking. On one hand, the sun's constancy is what makes life possible. Its brightness has not wavered beyond a narrow range for billions of years, giving Earth the stability to grow forests, rivers, and civilizations. On the other hand, its outbursts remind us that constancy does not mean perfection. Flares erupt, storms race across space, magnetic fields twist into chaos. Our world depends on the same star that occasionally threatens to disrupt it. Solar flares, in this sense, are fireworks with two faces. They are peril, able to blind satellites, silence radios, and shake power grids. But they are also wonder, lighting skies with auroras, painting our instruments with patterns of energy, and showing us that the universe is not static but alive with motion. What frightens also fascinates. What endangers also inspires. This dual nature is not contradiction, it is balance. The sun does not erupt out of malice, nor does it shine out of generosity. It simply exists as a star, obeying the physics of plasma and magnetism. We are the ones who interpret it, who see in its light both beauty and threat. To call it dangerous or benevolent is to place human meaning on something that simply is. And yet, that meaning matters. because it shapes how we live in relationship with the star. Our understanding grows each year. Instruments capture details once invisible, models predict storms with increasing accuracy, engineers design satellites and grids with defenses against the sun's moods. Knowledge does not remove danger, but it gives us resilience. In learning the sun's rhythms, we learn how to live more gracefully within them. Perhaps that is the deeper gift of solar flares. They are not only eruptions of energy but also reminders of perspective. They teach us humility, that our technologies are small compared to the power of a star. They also teach us wonder, that even danger can arrive wrapped in beauty, lighting night skies with colors that feel otherworldly. The fire that sustains us is never entirely tame. It is steady yet restless, reliable yet unpredictable. It gives life, and it unsettles the very systems born of that life. To live here is to accept this duality, to see fireworks in the sky as both hazard and marvel. And so this reflection ends where it began, with the sun itself. A star that burns, a star that flares, a star that sustains. Its fireworks remind us of our dependence and our fragility, but also of our capacity to endure, to learn, and to wonder. In its light, both gentle and fierce, the story of life continues.